I am Professor J. N. Mandal, Department of Civil Engineering, IIT Bombay. I will not teach you the ultraviolet or the sunlight degradation. This is as per ASTM D4355 or ASTM D5208 or ASTM D5970. The main objective of this kind of the test is to determine the reduction of the tensile strength of geosynthetic material from the exposure to ultraviolet light. The strength of geosynthetic material may reduce when the exposed in the sunlight for long time. So, you cannot keep the geosynthetic material for longer time in the sunlight, because geosynthetic material may degrade. So, what percentage of degradation it would be? So, geosynthetic material should be kept at a side below the 32 degree centigrade. For polypropylene and the polyethylene geogrid, minimum 70% of the strength should be retained after 500 hours as per ASTM D4355. For polyester geogrid, minimum 50% strength should be retained after 500 hours ASTM D4365. So, one should maintain that time. So, here now I will show you the equipment and the accessory required. So, this is Axion apparatus and tensile strength of the testing apparatus. This is the device for ultraviolet degradation. So, in this device you place the geosynthetic material. Before that, you have to perform that what will be that graph strength of the geosynthetic material, and then you can place the fresh material in the size of the graph strength, and then you place it on these ultraviolet devices for a particular the time about 500 hours, and then you take out the sample and determine the tensile strength of the geosynthetic material. Then you will be knowing what will be the percentage of the geosynthetic material retained. Next, what is the procedure for this geosynthetic material? Firstly, tensile strength of the specimen without UV exposure is determined in both machine and cross machine direction. Specimens are exposed to ultraviolet exposure in an Axion device at 0, 150, 300 and 500 hours. It consists of 120 minutes cycle light, only 90 minutes, and then water spray and light 30 minutes. After UV test, cut the strip or ravel strip, tensile tests are carried out on the exposure specimen. It will show the deterioration of the exposed sample. At least 5 samples are tested for the UV test on both machine and the cross machine direction. Now, how to calculate the tensile strength of the geosynthetics material? So, determine the average tensile strength of geosynthetics without UV exposure and also the average tensile strength of the geosynthetics with UV exposure. So, calculate the percentage loss in strength. For polypropylene and polyethylene geogrid, minimum 70% strength should be retained after 500 hours as per ASTM D 4355. But in case of for polyester geogrid, minimum 50% strength should be retained after 500 hours as per ASTM D 4355. So, one has to maintain the time and one has to know what kind of geosynthetic material you are performing the UV degradation. So, this UV light degradation is very important because you cannot place the geosynthetics for longer time in the open sunlight. So, there is a possibility for the degradation of the geosynthetics material. Even then some Middle East country where temperature is too high, so you cannot keep more than 2 weeks or 15 days, then sometimes this geosynthetic material turn into the dust. So, one has to be cautious and take care about the UV radiation of the geosynthetics material or what will be the vandalism of the geosynthetics material. Next, I will discuss the gradient ratio test, and this gradient ratio test is very important. And when the any geosynthetics material may clogged, because most of the kind geosynthetic material also used as a drainage and the filtration, and it is flow related problem. For example, if you wanted to use the geosynthetic material as a drainage material, then there is a possibility of the clogging between the soil and the geosynthetic material, then the drain will be choked and there will be no flow as it happened in the conventional method. As you do in the conventional method, you excavate and then you fill up with the good quality of aggregate, compact it, and after a passage of time, because the surrounding of the good granular material, there is a clay, so there is a possibility for the choking of the drainage. So, instead of this conventional method, if you can place a layer of geosynthetic material surrounding the good quality of aggregate, then there should not be any choking and there should not be any clogging of the geosynthetic material, then flow will be perfectly all right. So, for this purpose, what we need, that what will be the gradient ratio, what kind of the material you should select and what should be the gradient ratio of the geosynthetic material, that is very important to us. So, for example, that if the gradient ratio greater than 3, you will be able to tell this is clogged V material. So, you can make use. So, now I will talk about the gradient ratio. So, here the objective is to determine the clogging potential of geosynthetics. In introduction, clogging due to the soil particle cloth, reduction in the permeability of the geosynthetic material. The ratio of hydraulic gradient of soil to geosynthetic system to hydraulic gradient of soil alone is called gradient ratio. So, gradient ratio tests are conducted on soil having the permeability more than about 10 to the power minus 5 meter per second. It is suitable for the sandy and silty soil, where the coefficient of the soil should be less than equal to 10 to the power minus 7 meter per second. Now, this gradient ratio, if it is a less than 1, then you can say it is a piping. This is the acceptable criteria for gradient ratio. If the gradient ratio greater than 1, you can say it is clogging. If the gradient ratio greater than 3, you can say it is a severely clogging. If the gradient ratio is 1, then you can say stable. To perform the test, you require what will be the equipment and the accessory. So, you require soil geotextile permeameter, constant water head device, manometer board, soil support screen, thermometer and stopwatch. So, I show you that what is the type of the equipment, and this is the equipment already is developed in our laboratory here. This is photographic view of the gradient ratio. This is the gradient ratio, and geosynthetic material is placed somewhere here, and the soil, and at a different parts. I will show you in detail about the photometric gradient ratio of this soil sample. For example, that here this is the this is the devices which is 100 millimeter in diameter, and this is the bottom, this is the water outlet here, this is the bottom vent valve, and there is a port. This is port 1, this is port 2, this is port 5, and this is port 3, and this is port 5, and in between the distance between this to this port 3 and 5 is 50 millimeter, and this to this port is about 25 millimeter, and this is the water is inlet. This is the top section, and this is the O-ring gasket. This is the center of the section, this is the support screen, and this is the bottom section. And from this support stand, and this is the support stand, and top vent valve is here. And so, this is the schematic view of the gradient ratio test. Now, what is the procedure to perform the test? So, permeameter has to be clean and dry. Place the soil carefully on the permeameter, insert the geotextile and place the permeameter section together. Connect the constant head device and manometer device with permeameter. After saturating the sample, adjust the constant head device to maintain hydraulic gradient as unity. Record the time taken for collecting required quantity of water. Also record the individual manometer reading. So, here one point you have to be remember that hydraulic gradient should be 1, and this flow will obey the Darcy's law. Now, you have to repeat the procedure for different value of hydraulic gradient obtained by increasing the rate of inflow to a constant head apparatus. So, for example, that how to calculate this gradient ratio. So, here I am showing you some calculation. So, hydraulic gradient that is I is equal to delta H by L, where delta of H is equal to difference in head. Okay. And L is the length of the soil sample. L is the length of soil sample. Okay. And permeability, K is equal to Q divided by I into A to T, where Q is equal to discharge. Q is equal to discharge, that is centimeter cube. And A is cross sectional area. Cross sectional area. And T is time taken. So, this is time, this is taken. So, Gradient ratio, if you designate it at GR, which is called the gradient ratio. So, gradient ratio will be I of soil geosynthetics GS divided by I of soil. So, you can determine that what would be the I of soil geosynthetics and what is I of soil, then you can determine what should be the gradient ratio of the geosynthetic material. I will show you some view of this. Here you can see that this is all port and this is the soil sample, geosynthetic material is here, and this is 1, 2, 3, 4, 5 and 6. So, these are piezometer number. So, you can determine what would be the P of 1 here, then this is P3 and this is for P5, this is for P6, this is for P4 and this is for P2. Okay? And this distance from here to here Z1, which is 25 millimeter, and from here to here Z2 is about 50 millimeter. So, gradient ratio you can calculate knowing the value of H1, H2 and Z1 and Z2. So, H1 at this port will be equal to, this is P3 plus P4 divided by 2. Okay? P3 plus P4 divided by 2. And here H2 is equal to P5 plus this is P5 plus P of 6 divided by 2. So, you know what is H1 and you know what is H2 and you know it is fixed that Z1 and Z2. So, you can calculate the gradient ratio, that means is equal to H1 by Z divided by H2 by Z. So, Z1, Z2 is fixed, only you can measure what will be the H1 and what should be the H2 from the piezometer, and then you can determine that what should be the gradient ratio of the geosynthetic material. And if the gradient ratio is greater than 3, then you can say that this is the Clarke-Bee material. So, one has to be taken careful about the proper selection of the geosynthetic material for the application of the drainage and the filtration, and particularly also for the erosion control. On the one side, you should know that what should be the particle size distribution of the soil, and on the other hand, you should know what should be the gradient ratio of the geosynthetic material. So, knowing this gradient ratio value, so you have to be select that proper kind of the geosynthesis material which is clogging free. That is why this is the more important to know the value of the gradient ratio and how to evaluate the gradient ratio of the different types of the geosynthesis material. So, now we will discuss the geoform material. So, geoform material, it is in textile term called the expanded polystyrene material, or it is called the EPS. And in general we talk about this material as a thermocol, what you take a cup of tea or coffee. So, this geoform material in geotechnical engineering term is a superlight material. Its density is 100 times less than the density of the soil. And this geoform material, you should know what should be their defined types of the property, physical property, mechanical property, chemical property, etc. That is what we will discuss. So, for the geoform material, what should be their function? And this geoform material is available in different size and the shape. It may be in the rectangular form, it may be in the cube form, it may be in the hexagonal form, it may have it in the honeycomb form. So, different types of the geoform material will be available and their density also will vary. It may be 11 to 62 or more. So, what kind of the geoform material you should select for a particular infrastructure? Now, what I mean that geoform basically a block or a planar. So, it is like a block or it is like a block, in the rectangular shape or any shape, block or the planar rigid cellular foam polymetric material used in geotechnical engineering application. So, this material its primary function is a lightweight. So, this is lightweight, one of the function is a lightweight, and this lightweight material can be used in the highway. You can use this geosynthetic material in a highway or for the national highway or the rural highway or any construction of the embankment on the soft soil. For example, you wanted to construct an embankment on the soft soil. So, where there is a scarcity, you have the good quality of the aggregate. So, you do not need the good quality of the aggregate and your construction will be very fast and time is very less. You do not want to need any kind of the ground improvement system. You can place the geoform material in the form of the block on the very soft soil. So, it was like this. Suppose if this is the ground surface, okay, you can place the one layer of the geotextile material here. This is geotextile material GT, and you can construct the embankment on the very soft soil. You do not need any kind of the compaction. So, this is the block. So, this is the geoform block. This is the geoform block. This is what you call the geoform or expanded polystyrene material. And This portion you can fill up with the soil and the grass can grow. So, it looks greenery both the side, the grass can grow, and asphalt overlay you can place on the concrete, or asphalt overlay you can place on the top. So, you can make this embankment using the geofoam material. It is super light material, its density is 100 times less than the soil. So, this is one kind of the application of geofoam in the highway. So, here the lightweight is one of the function. Now, you can use this material for compressible inclusion. Compressible inclusion behind the retaining wall. So, this geofoam material you can use back of the retaining wall. So, in that case there will be a substantial reduction of the pressure on the wall. So, how that pressure can be reduced due to the application of the geofoam material, what geofoam material act as a compressible inclusion. For example, that if you draw a relationship, suppose this is the lateral, this is lateral earth pressure, this is lateral earth pressure, and this is the depth. Okay? You know linear when it is at rest, this is a linear, and when it is active. So, this is active, it is less than the rest condition, but when you use the geofoam material, so it should be reduced, this is reduced. So, this is conceptual lateral earth pressure distribution under different in situ stress condition. You know what is K, K is equal to sigma H by sigma B. You know what is K0, you know what is K active, you know what is K passive. And generally this is, you can see there is arching, formation of the arching, and that is why it is reducing. And most of the cases back of the retaining wall, it fell at the middle of the wall. Majority cases in the infrastructure application and fail of the reinforced soil retaining wall due at the middle of the wall. And apart from that, this geofoam material is also act as a thermal insulation, and also another function which is drainage, and also is another function also as a noise barrier. You can use geofoam material as a noise barrier. But in case of the thermal insulation, when there is a difference in the temperature or any storage or any industrial building or any garage or any shelter dwelling or any refrigerator below the ground, there is a possibility of the temperature differences. And for the temperature differences, what we conventional method, most of the time we use the aggregate, we use the concrete, and there what temperature will be the more. But alternative to the aggregate or the concrete, one can make use of the geofoam material, and it is a very good as a thermal insulator. So, we will also evaluate how to determine the thermal insulation and how it works, and what will be the difference in the temperature, because different material has a different kind of the thermal insulation. So, what kind of material we should use, and what will be the difference between the conventional material, aggregate, brick, whatever it may be, concrete, with respect to the geoform material. That also we will discuss later.